Hello, welcome back to the series of Network Security Essentials. In this session, we will see one more important algorithm that is a pretty good privacy. PGP. Okay, so this algorithm is basically providing privacy, then integrity, authentication, non-repudiation in the sending email. Means for email security, we are using PGP algorithm, or you can say the protocol, right? So this algorithm is invented by the Phil Zimmerman in 1991, which is a very important algorithm because this algorithm is providing, as mentioned, security, privacy, integrity, and all. So this PGP algorithm uses a digital signature. A digital signature in the sense combination of hash values and public key. Okay. So in this case, using a digital signature, it is providing integrity, authentication, and non-repudiation, as well as it uses combination of secret key as well as a public key for providing the privacy. That is why this algorithm, uh, now we can say that a digital signature uses one hash function, secret key, and two public and private keys. Okay, so this algorithm is freely available and mostly used in email securities for providing the uh, authentication through the digital signature. In addition, it provides confidentiality through the symmetric block encryption methods. So how it actually working, we will see through this algorithm. You can see here the sender side working. Okay, let's consider sender A, and this is the B, receiver B. How PGP algorithm is used for providing the security. Let's consider here our original message. You can see the original email. Only few steps you have to remember. As mentioned, it is using the digital signature. Okay, digital signature is a combination of hash value and public key encryption. So hash value is mentioned here and public key is also given here. So both the combinations are used in PGP algorithm. We were talking about email. So this is our original email, for example. So on this email, what we are applying? We are applying the hash value, right? So through this hash value, we are getting the digest value. Means on original email we are applying hash function and we are getting the digest value. So that digest value we are encrypting through the private key of A. Here we have mentioned A, means sender's private key we are using for encrypting the digest value. Okay, so after encrypting we are getting new signed digest value. Remember that on a original email we are applying hash function, and through the hash function we are getting digest value. That digest value we are encrypting through the sender's private key, and then we are getting the new signed digest key. So this digest value along with the original email, means combination of these two, we are encrypting. So see here, combination email plus signed digest, that is the combination of these two. Again we are encrypting, again encryption algorithm we are applying here. And here remember that one time secret key is used for encryption. So combination of signed digest and original message, again it is encrypted through the one time secret key. And then the encrypted message, again it will be added with whom? With the encryption. See, here is the key of this algorithm. Whatever encrypted message is there. So, how we are encrypting the message? I mean, the combination of email and signed digest, we are uh, encrypting through one time secret key. That one time secret key also encrypted. How it is encrypted? Through the public key of the receiver, or you can say the B. Here as mentioned, a receiver A is nothing but the B. So this one time secret key is also encrypted through the base public key, and then the outcome of encrypted one time secret key and encrypted email plus signed digest we are sending to the receiver. So here new value, or you can say new data we are generating for sending to the receiver, that is encrypted secret key and a message plus digest. So this particular combination we are sending to the receiver. Now what about this receiver stage? See here, encrypted secret key and a message and digest is received, for example, at the receiver end, and receiver, now here receiver is encrypting that secret key, right? Encrypted secret key is used for decrypting purpose. Remember that here in a encryption we have used as, I mean sender's private key, but here sorry, in a decryption we are using the B's private key. Fine. And parallelly, that encrypted message plus digest we are decrypting again one time secret key, and then finally we are getting the email. Okay, so here the step we have followed means whatever activities we are doing in the sender side, just we have to reverse that activity. Okay, here now again we are decrypting that message through as public key. Here as private key we have used. Here we are using the as public key for decrypting the email, and after decrypting the email we are getting the digest value. So here see, after before encryption it was the digest, but here after decryption there is a digest value, and parallelly that email on that email we are applying find hash function, and here also we are getting the digest value. So both these values we are comparing with each other for checking whether the received message is correct or not. Means this PGP uses hashing and combination of three keys to generate the original message. What are the three keys? Public key, private key, and one-time secret key. So the receiver receives the combination of encrypted secret message and digest in the first step, as here we have mentioned, right? So here you can see here, and then the encrypted secret key is decrypted by using receiver's private key to get the one-time secret key. So here the one-time secret key can be generated through the secret key by using the receiver's private key, right? So this secret key is then used to decrypt the combination of message and digest. And lastly, the digest is decrypted by using sender's public key. See, remember that here, sender's public key we are using. Okay, and the original message is hashed using hash function to create the digest value. Both the digests at last we are comparing. If both them are equal means all the messages are correctly received at the receiver side. Means security is preserved. So this is the simple funda of PGP algorithm. Thank you.